Common problem faced by the ResLife staff here at Emory is finding staff members to work over winter break. Currently, an Excel sheet is sent out to all residential advisors where they can fill in their availability information. Then, Kayla manually sorts through everyone's availability to create the staffing schedule. The goal of our project was to automate this process. Using Google Forms, VBA, and Excel, we created a macro that takes in the availability information, transposes it into a solver model, and creates the schedule that optimizes RA's preferred shifts. So the first piece of our tool is the RA winter break Google form that will be sent out to all of the RAs. The RAs will fill out their name and choose the residence hall area that they prefer. The areas are divided into four. So there's A1, A2, A3, and A4, and they can pick which one they prefer. Then they will fill out their availability information, where a 0 means they're unavailable, a 1 is that they're available, and a 2 means that it's the shift they prefer. So in order to get our sheet to look as the final model, we had this Google form output. So we have all of our RAs on the rows, and then their residence hall and availability. However, we had to transform this to make it fit into our solver model. So we created this VBA macro that would transpose the data that it was outputted in the Google form into our solver model. So we set our form sheet as the sheet that comes from the Google form, and then the output sheet is the sheet that contains the macros with our solver model. And the rest of the VBA code here is transposing that data into the format that we want. Once that process has been complete, the availability comes into a table that looks like this. And we now have the setup that we need for our solver model. So our decision variables are here in yellow, and they are represented by binary variables, as we want the decisions to be yes, that person is working, or no, that person is not working. We also have one initial constraint of the availability. So all of the decisions must be less than or equal to the availability that a person is listed so that they are not working a shift they can't attend. An additional constraint is that each RA needs to have at least one shift. So the sum of the total days that they are working or shifts that they are working has to be greater than or equal to 1. Additionally, there can only be one RA in each building per day. So we have a constraint such that the sum of each area per day is equal to 1. Additionally, Kayla, as the director, will only work shifts if there is no one else available for that day. So we had to set up a linking constraint using the M method, where instead of if we have production, there's a constraint, we want Kayla to have a condition if there is nothing else. So we set the constraint that 1 minus Kayla times M must be greater than or equal to the sum of the other RAs. Lastly, we have a constraint that each person can only work in one location on any given day. So the sum for the 4 areas for each RA per day is calculated in this table, and all of those values are set less than or equal to 1. In order to optimize our solver model, we came up with the objective function of a fairness score. So we wanted to maximize the amount of preferences that each RA was given, so that they would weight those shifts that they wanted more. So our fairness score is the sum product of the availability times the decision variables. This ensures that there is a weight when someone puts a 2 and they are more likely to get that shift. So once we have populated the data into our table, we can hit form the schedule, and we see that a schedule matrix has been generated, where we can now view the schedule for the 5 days in all of the areas.